Okay, some people had some questions about this question on the velocity versus time graph worksheet, so we're going to do it together. Now remember, the first thing you're going to do with every single graph is you're going to look at what type of graph it is. So this is a velocity versus time graph. So the first question says, at what time are the cars going the same velocity? So this is a velocity versus time graph. So to see whether they're going the same velocity, I don't need to know anything about physics. I'm just reading the graph. So car A and car B, at this point, they're both going the same velocity, and that's 90 kilometers per hour. But it says at what time. So when they're both going 90 kilometers per hour, it's at this time here, which is 3.0 times 10 to the negative 3 hours. Now, if you look at car A, you can see that car A is, because this is a velocity versus time graph, you can see this one's accelerating, and then you can see this one's moving at a constant speed. Okay? So accelerating, constant speed. And this is a very common physics problem, either on a graph or where you have to work it out, where you have someone where they're going at a constant speed and someone who's accelerating, and you have to figure out like when one person passes somewhere else or something like that. Question B says, how far has car A traveled when they reach the same speed? So how far is the displacement? And the displacement is the area under the curve. So for car A, this is the area under the curve at that point. So this is a triangle. So to figure that out, I started doing it, and then I stopped the video. The area under the curve is a triangle, so it's 1/2 base times height. So it's 1/2 of 3.0 times 10 to the negative 3 hours times 90 kilometers per hour. Now notice that the hours cancel, and I end up with kilometers, which is how far. And when I do it on my calculator, what I'll do is I'll say 3 EE minus 3 times 10 to the negative 3, times 90 equals, divided by 2 equals, and I get 0.135. So that said how far, and that would be in kilometers because that's what's left. All right, now it says at what time does car A reach car B? So here, when they reach each other, this means that they're side by side. When they're side by side, which means they've covered the same displacement, what this means is the area under the curve of one is equal to the area under the curve of the other. You cannot tell by looking at the graph when the area under the curve of one is equal to the area under the curve of the other. You can't just do trial and error. You're going to calculate it. So this is what we're going to do. And you might have a problem like this as well, where you're not looking at a graph, but you have to calculate, let's say, between a sprinter and a runner, when they're side by side. It's just a classic physics problem. So what I'm going to do is going to make a table. So I'm going to write car A, and then I'm going to do car B. Now, just so these have two different motions. So car A, this one is accelerating. Car B is moving at a constant speed. And why is this important? Because there's different equations for acceleration than there are for constant speed. Now, we want to know how far it went. So how far, we want to find x. And we also want to find here how far, and we also want to find x. So basically, we want to know when is this x going to be equal to this x. So first, let's look at the motion, and we know that for something accelerating, x is equal to VIT plus 1/2 AT squared. And sometimes I say V naught because that's what we use in AP Physics, and sometimes I get confused because I'm doing both classes. So the initial velocity is equal to 0. So this whole term goes to 0. So let me just get rid of that. So now the equation for this one is x is equal to 1/2 AT squared because that car is starting from rest. For something that's moving at a constant speed, we know v is equal to x over t. So x is equal to v times t. So now here's our equation for x. So the question said, at what time does car A reach car B? So when they reach each other, this x is equal to this x. Because these x's are the same, see, the problem is here I have too many unknowns. I don't know x and I don't know t. I know A, I know v, but I have two equations and two unknowns. So one way to algebraically solve when you have two equations and two unknowns is I have two variables, x and t, so when these x's are equal, I'll just set this one equal to that one. So when I do that, I'm going to say that 1/2 at squared is equal to vt. Now, I need to simplify this. So the first thing that I can do is I can factor out a t. So I can factor out a t here and a t here. So now I have 1/2 at is equal to v. But I want to solve for t, so I'm going to rearrange my equation to solve for the unknown in terms of the known. So what I'll do is I want to solve for t. So I'll leave t where it is because right now it's in the numerator. So what I'll do is first I'll multiply both sides by 2. So I have at is equal to 2v. Then I'll divide both sides by a. So t is equal to 2v over a. So now I have my unknown in terms of my known, and then I can substitute in my values and solve. So 2 times my average velocity, which they said was 90 kilometers per hour, times my acceleration, which, what was the acceleration? 30,000 kilometers per hour squared. Now, how did I know what the acceleration was? Well, to find the acceleration, how would you find the acceleration? Well, and I don't remember if we did it. Here's my graph. So for car A, the acceleration is going to be the slope of this line. Because remember, on a velocity versus time graph, the slope is the acceleration. So I have to find, so I would do delta y over delta x for this one. And once I found the acceleration, that it was 30,000, then I would substitute that in here. And then when I do this, the time comes out to be 0.006, which is 6 times 10 to the negative 3 hours. Now, going back to finding the slope, I always find, when you find the slope, you find the slope of any 2 points on the line. So I see here that when I found the slope, I just did this point, 90 minus 0 over 3.0 times 10 to the negative 3 times 0. So remember, to do that, slope, delta y over delta x. If it goes through the origin, y2 minus y1 over x2 minus x1. So I did 90 kilometers per hour divided by 3.0 times 10 to the negative 3 hours minus 0 minus 0. So a kilometer per hour divided by an hour is a kilometer per hour times 1 over an hour, which is a kilometer per hour squared, which is the correct unit for acceleration. So this is how I got this value, and that's how I found the time. Now you can have a problem like this. I don't remember if we have one like this for homework. So you can have the same type of problem without a graph, where they say like a guy is accelerating and another guy is running at a constant speed, and it might say at what point does the runner who's accelerating reach the jogger who's running at a constant speed or something like that. So you just have to know that the two x's are equal, and then instead of you finding the acceleration from the graph, they'll tell you what the acceleration of the runner is. So these problems really aren't that bad. You just have to do it step by step. And when you do your work organized, here's car A, here's car B, what's happening, this one's accelerating, this one's moving at a constant speed, what am I looking for? It asks how far they go, what do I know about something that's accelerating, what do I know about something that's moving at a constant speed. The more you write down on paper, the less likely you are to make a mistake. And one of the things that we've learned in this class is when you're not sure how to do a problem, if you start writing stuff down and you look at it, by looking at it, because most of us are visual, it'll kind of help us to figure out what to do. So this problem really wasn't that bad. Then at D says, how far have each of the cars traveled when they're side by side? So you could take either one of these equations and substitute in the values that you just found for time. Well, obviously this equation is much, much easier. So I would do that one. So for D, I would say x is equal to v times t. So the speed is 90 kilometers per hour times the time, and then I would, this was my time I'm going to put in here, so 6.0 times 10 to the negative 3, and then I figure out how far they went. Then for part E, it says which car is ahead, and again, you have to look at the graph, and at that point, you can look and say, okay, which area under the curve is larger. So over here at 8, car B is this rectangle, but then car A is this triangle plus this rectangle. So sometimes you can look, and then sometimes you would have to calculate. So here you can see that there's more area under A than there is B for that same amount of time, because you can just like look at the shapes here. So that's how you do this one. So again, whether we have this type of thing on a graph or we have it on a problem, it's the same concept. And, you know, just to lay it out and think about it. And once you do a problem like this, it's really not that bad anymore.